Hello everyone, welcome to our YouTube channel Astronaut Civil. Today we are going to start a new course, mathematics. Okay guys, so in mathematics first of all we are starting with matrices chapter. Okay, so guys, this is the syllabus also. Basic types of matrices, properties of matrices, then we'll see rank of matrices, then matrix form, PAQ form, inverse of matrices. Then there are system of homogeneous and non-homogeneous equation. Then linear dependent and independent vectors. So this is the syllabus also. Okay. So you can write it down also. Okay. So from basics we are starting. Okay. And going in details. So let us start. So basics types of matrices. So you all know what is matrices. So matrices is nothing but the arrangement of row and column in square or rectangular form. So this is the simple definition of matrix. So this is the matrix A, which is given as elements A11, A12 to A1n. So similarly, second row A21, A22, A22n. So similarly AM1, AM2, AMN. So this is the notation of elements, which means here A11 means element in first row and first column. So similarly for this element A12 element means it is the element at first row and in second column. So similarly this is AMN, which means here the element in mth row and mth column. So this is the, and here this is the a matrix. It is denoted by m into n. So this is the order, so which denoted as order. First m means number of rows and second n means number of columns. So this is the notation here. So next one, so we are studying difference in matrix and determinant. So simply matrix is denoted by like this symbols, and this is the determinant symbol. So in matrix may in the form square or rectangular. In square matrix, so order of the matrix m is equal to n means here the number of rows is equal to number of columns. Here the number of rows is equal to number of columns. In rectangular matrix, number of rows is not equal to number of columns. So simple definitions here. And here determinant only possible for square matrix only. If the square matrix is there, then and only then the determinant is possible. Otherwise, if the rectangular matrix is there, so then there will be no determinant. So next, here determinant. So first of all we will see how to calculate determinant of 2 by 2 matrix. So let us take this example here. So how we can calculate here? So cross multiplication of this diagonal and minus cross multiplication of this diagonal. So here e square into e square minus e raised to power x into e raised to power x, so that will be here. So is equal to, if you solve this, e raised to power 4 minus e raised to power 2x. So this is simple. And if you want to find out 3 by 3 matrix determinant, so then you have to keep in mind, if so while taking first row element, so you have to take positive, okay, then negative, then positive if 3 by 3 matrix is there. So how to calculate 3 by 3 matrix determinant? So let us first, you have to take here 1, so 1 in round bracket, so minor of this element, so 4 into 2 minus 5 minus here second element minus 2. So you have to leave this row and this column, so there will be element here 3 into 2 and 5 into 1, so 3 into 2 is 6 minus 5 plus last element 3 here bracket 3 minus 4. So how we'll get this? So here, so this we have to leave, and here this minor 3 4 1 1. So 3 3 1 3, 3 into 1 3, and 4 into 1 4. So 3 minus 4. So if you solve this, minus 2 will get. So here we'll see one trick to find out determinant of 3 by 3 matrix. So let us copy paste this matrix from above here. Okay guys, so then write down first column and second column as it is to this side. So you will get 3 rows and 5 columns. So like this here, and you have to mark this diagonal. First of all, this 3 diagonal like this. So what you have to do, you have to just multiply this diagonal element. So first diagonal element, so 4 into 1 4, 4 into 2, that will be 8. So here write down 8 here. Then second diagonal, you have to take 5 into 2 10, 10 into 1 10. So write down this 10 here. Again, if you add 3 into 3 3, 9, 9 into 1 9. So if you add these 3 diagonals multiplication here, so then we have to subtract this type of diagonal multiplication. So you can just see here, 4 into 3, that is 12, 12 into 1, that is 12, minus 12, plus in round bracket you have to write it all the things. Okay, then 5 into 1 5, then 5 into 1, that is also 5. So write it down 5, plus 3 into 2 6, 6 into 2 12. So write it down here. So if you solve this, again you will get same number. Okay guys, so simple. This is the trick. Okay guys, so next one. So properties of determinant. Here simple. If any 2 rows or any 2 columns are same, then determinant is 0. Simple. So here let us see, 1 0 minus 2, 2 3 0, 1 0 minus 2. So these elements are first column and second columns are same, so therefore determinant directly you can say 0. So similarly, if there are 2 rows means similar, so then also determinant is 0. So here you can see these 2 rows are same. Okay guys, so determinant directly 0. So if any 2 rows or columns of the determinants are same, then determinant is 0. So similarly here, second point, if determinant A having element 1 2 0, 1 minus 1 3, 2 4 0. So here you can see the third row is the multiple of first row. Okay, if you multiply the first row by the 2, so you will get the directly third row. So then if the means indirectly we are getting the same rows, so therefore determinant is 0. So if any 2 rows or columns are in the ratio, then determinant is 0. So simple, keep in mind these sentences. These are very important in objective type of examination. Directly questions like this can asked. So here, if one of the rows or column is 0, then determinant is 0. You can see here this matrix A. Here 3 minus 2 0, 2 minus 3 0, minus 7 minus 2 0. So here in third column there all elements are 0. So directly determinant 0. Next we are starting with the types of matrices. So first of all, row matrix. Here number of rows is only 1. Here only 1 rows and any number of column, means here it should be only 1 row. Okay, it may be n number of columns. Okay, so here you can see this is the example 1 2 3 up to n.
So number of columns may be n. Okay, then column matrix similar like row matrix, but it is column. So number of column is only 1. So similarly there may be m number of rows. So next, square matrix. So number of rows is equal to number of columns. So m should be is equal to n. Then only then that is square matrix. Okay, यहाँ पे एलिमेंट की कोई बात नहीं की है. ओके, कि एलिमेंट कैसे होने चाहिए, बट देयर में बी मीन्स नंबर ऑफ कॉलम is equal to number of rows. Okay, so here next one, rectangular matrix. So here rectangular matrix means number of rows is not equal to number of columns. So here 1 2 3 4 3 2, so order it can be represented by 3 rows and 2 columns, so that will be like this. So null or zero matrix means here simply zero element. Okay, so here zero matrix, it requires to create space, means whenever we want to create space, so then we have to just use this null matrix. Okay, so basically it is used in languages, okay, for coding and decoding. So next one, singular matrix. So singular matrix means what? If you calculate the determinant of matrix, then if you will get determinant of A is equal to 0, so then that is singular matrix. So let us take an example here. Matrix 1, sorry, determinant A is equal to 1 2 3 6. So here determinant you will get directly 6 into 1, that is 6. 6 minus 3 into 2, that is 6. So 6 minus 6, 0. So this is singular matrix. So non-singular matrix means what? If determinant is not equal to 0, so then that is non-singular matrix. Okay, so next, upper triangular matrix. So here some points. So lower triangular will be 0. In upper triangular matrix, lower triangular element are 0. So that is the simple definition. Okay, here in upper triangular matrix, below diagonal elements are 0. Okay, so here next point, every element below the diagonal is 0. That's what I told you. Okay, so diagonal and upper non-diagonal elements may or may not be 0. Means here below diagonal element 0. Okay, so there may be any 0 above diagonal element. Getting? So this is simple. So similarly, lower triangular matrix, here it is the new definition here. This is very important, basically as asked in GATE. Okay, so A21 is equal to A31 is equal to A32 is equal to 0. Okay, so here Aij is equal to 0 for I greater than j. Here you can check what is the position of this element, 0. So here second row and first column. So A21, so here I, so here if you write like this Aij, so here I is greater than 0, so 2 is greater than 1. So similarly you can see by pausing this video. Next, lower triangular matrix. So in lower triangular matrix, above diagonal elements are 0. So you can check here Aij is equal to 0 for j greater than 1. Okay, so here it is the position A32, so sorry A13, so Aij, so j is greater than I.
So next one, diagonal matrix. So it is a square matrix in which all non-diagonal matrix elements are 0. Means here let us consider matrix A is equal to 1 0 0 0 2 0 0 0 3. And see here diagonal elements are non-zero only, that is nothing but diagonal matrix. So here see Aij is equal to 0 for I is not equal to 0, and Aij is not equal to 0 for I is equal to j.
So diagonal elements did not be same, and here diagonal matrix is equal to upper triangular matrix plus lower triangular matrix. So keep in mind these sentences, very important. You can see here unit or identity matrix. It is a diagonal matrix A in which all diagonal elements is 1. Unit or identity matrix means what? Here it is the diagonal matrix, okay, in which all diagonal elements are 1. Here aij is equal to 0 for I is not equal to j, and aij is equal to 1 for I is equal to j. Simple definition है, ठीक है guys. So here next one is scalar matrix. So it is the diagonal matrix in which all diagonal elements are same. It may be 1, it may be 2, it may be 3, but all diagonal elements are same. That is nothing but the scalar matrix. So every unit matrix is a scalar, but every scalar matrix is not unit. Okay guys, so every unit matrix is scalar, but every scalar matrix is not unit matrix. So simple. Here unit matrix can be scalar, but scalar matrix need not be unit matrix, because it should be it should be 1 only. Okay, then and only then there will be matrix called as unit matrix. So here keep in mind, this is note is very important note. Determinant of upper triangular matrix, lower triangular matrix, and diagonal matrix, unit matrix and scalar matrix is the product of diagonal element only. Means here determinant of this type of matrices is the product of diagonal elements only. Okay, simple. This is very useful note for calculating determinant. Okay, so guys, let us see transpose of matrix. Okay, it is denoted by AT or A dash. So here let us take this example. A is equal to 2 1 1 0 1 2. So this is the matrix of 2 by 3 order. Okay, so you have to just transfer rows in column and column in rows, simple like this. So first row becomes first column and second row becomes second column. So A transpose is equal to, then order will be also get changed. So 2 0 1 1 1 3. Okay, so here it is denoted by AM cross n is equal to AN cross M. So directly number of rows converted into number of columns, and number of columns converted into number of rows. So then here properties of transpose matrix. So A transpose of transpose, so which will become as A. Then second point, that is A plus or minus B transpose is equal to A transpose plus B transpose plus or minus. Okay, and if K into A transpose is equal to K into A transpose. So these are the properties. So remember these properties. Or A into B transpose is equal to B transpose into A transpose, and keep in mind it is not A transpose into B transpose. Okay, it is B transpose into A transpose. So this property is very important. Next one, symmetric matrix. Okay, so any square matrix of which A is equal to A transpose, that is nothing but the symmetric matrix. So here you can check, here A is equal to matrix, this matrix. Okay, if you take transpose of this matrix, so you will get same matrix. That is what symmetric matrix. You can check here. So A transpose is equal to A, or A is equal to A transpose, means indirectly A12 is equal to A21, A31 is equal to A13. Here you can check. So this is the element A11, A12, A12 is equal to A21, A31, A13 is equal to A31. So similarly you can check here, A32 is equal to A23. So means Aij is equal to Aij, that is symmetric matrix. Simple. you can write it all the things. So next one, skew symmetric matrix. It is the square matrix in which A is equal to minus A transpose. So here, see here, let's take matrix A. So 0 minus 2 1 2 0 3 minus 1 3 minus 1 minus 3 0. So this is 3 by 3 matrix. So if we take A transpose, so you will get rows converted into columns and columns converted into rows. So A transpose is equal to 0 minus 0 plus 2 minus 1 minus 2 0 minus 3 plus 1 plus 3 and 0. Okay, so similarly it means Aij is equal to minus Aji. Here A is equal to minus A transpose. Simple. Okay, so orthogonal matrix. So square matrix for which A into A transpose is equal to unit matrix, that is I. Okay, so determinant of this matrix, okay, that is nothing but plus or minus 1. Determinant of this matrix is plus or minus 1. Here one thing you should know, A into A transpose is equal to I. So multiply by A inverse to all here. So A into A transpose, sorry, here A into A inverse into A transpose means here, hey, this is A into A transpose is equal to this I into multiplication by A inverse. So here A into A inverse, which is converted into I from this, into A transpose is equal to this I into A inverse, that is A inverse. So I into A transpose, that is A transpose, is equal to A inverse. Okay, so like this it comes. It is not like that A transpose is equal to from this I by A inverse, sorry, A. It is not like that. Okay, because this is wrong, because division is not possible in matrix. Okay, so this is wrong, this is right. Okay, let us take any example here. So we have to find out the value of K here. Okay, if this is A is orthogonal matrix, so you can directly take determinant here. So 2k minus 3 is equal to 1. You all know, if this is orthogonal matrix, so then A into A transpose is equal to I. So similarly you can take 1 here. So 2k minus 3 is equal to 1. So therefore 2k is equal to 1 plus 3, so that is 4. So k is equal to 2. Simple. So here conjugate matrix, it is denoted by A bar. So it is if any complex number is x plus iy, then convert the sign of I. Okay, so x minus iy, that is x minus iy. So here let us take this example. A is equal to 1 plus I minus 1 minus I, 1 minus I. So simple conjugate of this A matrix is directly like this. So just you have to convert this I complex number signs only, interchange you have to, if the just you have to change the sign only. So here 1 plus I, so they are converted into 1 minus I is converted as minus I, so minus is converted into plus and minus is converted into plus. So properties, so here A bar bar is equal to A, and here A plus B bar is equal to A bar plus B bar, and if A bar into B bar, sorry, AB bar is equal to A bar into B bar. Okay, so here transpose of conjugate matrix, that is denoted by like this, A0. So A0 is equal to A transpose conjugate, okay, or which is equal to A bars transpose. Okay, this is the property. Then what is meant by Hermitian matrix? It is the square matrix in which A is equal to A0. Okay, which means A is equal to A transpose bar, simple. Or you can say Aij is equal to transpose of Aji. Okay, sorry, this is conjugate, sir. This is conjugate. Okay, so here let us take this one. A is equal to 1 minus j, 1 plus j, and 2. So you have to take transpose of this matrix A. So directly it converted as 1 plus j, 1 minus j, 2. So and again we have to take conjugate of this. So 1 and 1 minus I. This is j, sir. 1 minus j, 1 plus j. This is 2. Just you have to what you have to do for conjugate, just you have to interchange the sign of conjugate number only. Okay, so this is conjugate and this is conjugate. So what you have to do, you have to just convert plus sign into minus and minus sign into plus. Simple one. Okay, next one is skew Hermitian matrix, which means here A is equal to minus A minus A0. Okay, that is A transpose is equal to minus of A transpose bar, that is conjugate. So note, diagonal elements of Hermitian matrix are purely real. Okay, here keep in mind Aij is equal to minus of Aji here bar. And next point here, diagonal elements of skew Hermitian matrix are either 0 or imaginary. Okay, and last one, unitary matrix. Unitary matrix, that is A into A0 is equal to I. This is determinant of A is plus or minus 1. So similarly it is for like orthogonal matrix. Okay, so A into A0 is equal to I, that is unitary matrix.